Anyway, we're going to move on with Eddie's brilliant circle in the background. I'm going to show you 3 examples of definite integrals, areas to do with inverse trig functions, and a few tips and tricks that you need to evaluate them apart from just the normal ways that you would do things. Okay? So here's the way I'm going to approach this. When it comes to inverse trig functions, okay, all of the inverse trig functions, sine inverse, cos inverse, tan inverse, you want to consider their areas with regard to 2 things. 2 things you need to watch out for. The first thing is symmetry. Okay? Just like the original trig functions, there's an enormous amount of symmetry that you need to take advantage of when you're doing your definite integrals. We'll look at some easy examples and some trickier ones. Okay? The other thing you want to keep in mind is how similar they are to the original trig functions. If all you are working out is an area, if that's all you're interested in, okay, then it doesn't matter which functions you consider so long as you end up with the right number at the end. Okay? So, let's start with a very simple example. Let's draw ourselves sine inverse. Okay? Don't forget, you ought to have vertical tangents at your endpoints, and you should be slicing across about 45 degrees. Okay? So if I wanted an area that corresponded to this, what's that look like? If I'm ending at 1, that looks like it's about a half. From negative a half to a half of sine inverse. Okay? So let's form the integral. The integral for this would be from negative a half to a half of, and it's sine inverse, right? Okay. So what's the answer? It's 0, isn't it? On what grounds would you simply say it's 0? Okay, so specifically, I mean, symmetry is the idea, right? But there are many, many kinds of symmetry, right? So you need to specify which one's going on. So I would say equals 0 as sine inverse is a what kind of function? It's an odd function. Good. Okay, because your boundaries are, opposite of each other, that's fine. Now, let's change up the question a little bit. Suppose I don't want just the straight definite integral. Suppose I really do want the area that's shaded, okay? We're going to use symmetry again, but we're going to use it in a slightly different way. How can I go about this? Okay, so the first thing I could say is the area, not just an integral, okay, is going to be double. Now, what's the integral I should form? I could do it either way, couldn't I? But, you might as well go forwards rather than backwards and have positives rather than negatives, okay? So it's the integral of this, sine inverse. Okay? Now, we are used to evaluating integrals, right? But if you don't know integration by parts, you're kind of stuck at this point, right? Which is where we get to our next point here, that I want to make some kind of comparison with the original trig functions, which actually, even though maybe you feel kind of fancy because you do know what the primitive function of this is, it is actually much easier, just as an extension 1 student, to consider this in comparison to, well, new set of axes, let's draw ourselves sine x, okay? Sorry, Eddie, I'm going to destroy your circle. Is that okay? Bye. Don't worry, you can draw another one. Now, let's draw the corresponding part of sine x, okay? So what would that look like? Draw it over here. So just like I had my vertical tangents, I got my horizontal ones here. Sorry, I'm a little bit off. Now, where's the area I want? How does this, and really I'm just interested in, make it a bit more solid. I'm really just interested in that area, aren't I? Where is that on this diagram, if this is sine x? Well, these are x boundaries, aren't they? Right? Going from an inverse back to the original function, I want y values. And that makes sense because 1's up there. It's the amplitude, isn't it? So there's 1, there's a half, okay. Now the area over there is bounded to the x-axis. So the area over here ought to be bounded to the good. Okay, so this is the area I'm after. Okay? So, good. Now if I want to work out this area, the simplest way to consider it is just to remember that when I integrate, I don't get area above the curve, I get area below the curve, right? So let's call this area in here, let's give it a name, I don't know, something like, I don't want to call it capital A because that's over there. Let's call it B, okay, secondary area, okay. B, what's its area? What kind of integral would I form? Well, I'm back in x's now, aren't I? So it's from 0 to whatever this value ought to be. Now, I've chosen half for a reason, because it will give you a nice simple one. It should be pi on 6. Good. Okay, and you can almost see that if you've drawn that reasonably. You know, pi on 2 is over here, so your guesses are kind of bounded, right? So I've got my integral from 0 to pi on 6 of sine x. Okay, let's quickly work it out. What is it? You're going to have a primitive of negative cos from 0 to pi on 6. Okay, so negative cos pi on 6, what's that? That's negative root 3 on 2, isn't it? Yes? I've got a double negative happening, so watch out. I'd usually subtract here, but I should actually have a plus. What's cos of 0? 1. Okay, there you go. So that's area B, okay? I want this area though, the one that I've shaded over here. So how am I going to get that area out of this one? Yeah, I'll need to know what that whole rectangle is, won't I? Where is it? I want to know what this whole shape is, and then I can subtract B. You okay with that? So now I'm going to say A is equal to, it's half pi and pi on 6 wide. So that's pi on 12. And I'm going to subtract this area. If I subtract it, sorry, I meant pi on 12. There you go. Pi on 6 times a half. Yeah, good. If I subtract it, all my signs flip. So this is what I get. Is that okay? Is that right? Cool. So I've worked out one piece. Now I can come back over to my original question, and of course I don't want one, I want two of them. Yes? So the real area that I'm after, this whole lot, is going to be what? Pi on 6 plus root 3 minus 2. Is that okay? Units. Okay, there you go. So there's two things to consider. Both of them are areas, but they use the symmetry in different ways. Okay?